Welcome to 13.6, unit circles. We're going to find the coordinate points along the unit circle. So first off, a unit circle is a circle with a radius of 1 where the center is at the origin. A couple things you need to know. Every single point on the unit circle follows the pattern of cosine theta, sine theta, where theta is the angle of how much it opens from the starting position of the unit circle. So tangent theta would be sine divided by cosine, or y divided by x. So we do need to remember these in order to solve the unit circle here in a second. Alright, to start us off, the center is 0, 0. So I'm going to go ahead and put that. We're in quadrant 1. I'm going to deal with a couple of points at a time. To the right, we moved 1 to the right, so that's 1, 0. And the top point would be 0, 1. Okay, so the starting position is at 0 degrees, but it's also the ending position, so it's also 360 degrees. So there's two different angles for this one point, so we can fill that in. It's 0 and 360. To find radians, we multiply by pi over 180. So it is 0 times pi over 180 is 0. 360 times pi divided by 180 is 2 pi. So the radians, the starting position is 0, the ending position is 2 pi. So the tangent would be sine divided by cosine, y divided by x. 0 divided by 1 is 0. Same for 360, because they're the same point, they're the same position. Alright, let's talk about the next point. So I'm going to be drawing a bunch of right triangles, which you do not have to write down. You will want to write down the coordinate point, and then you'll want to hold off until I talk about what the actual degrees place is. So the first triangle I'm going to draw is this coordinate point right here. This is a 30, 60, 90. We're dealing with the 30 degree angle because that's where it is from the center. Okay, but on the 30, 60, 90 we have the short leg is 1, the hypotenuse is 2, and the long leg is radical 3. Now that's not really true, because we know the full unit circle is 1 away. So this could not possibly be 1 or 2. But we're going to use these coordinate points in order to find our cosine theta, sine theta. So the cosine of 30 degrees is square root of 3 over 2. The sine of 30 degrees is 1 over 2. So that's our coordinate point. Is that square root of 3 over 2, 1 over 2. The tangent would be sine divided by cosine, 1/2 divided by the square root of 3 over 2. What you get is 1 over square root of 3, which we rationalize to square root of 3 over 3. So let's get rid of this right triangle. This was a 30 degree angle. To change that to radians, we multiply by pi over 180. 30 times pi over 180 is pi over 6. So that is the radian location. Alright, our next right triangle cuts it in half. Now half of 90 is 45 degrees, so this is a 45, 45, 90. The side lengths of the 45, 45, 90 are 1, and radical 2 is the hypotenuse. So the cosine would be 1 over radical 2. But we rationalize it to become radical 2 over 2. Same with the sine. So it's radical 2 over 2, radical 2 over 2. The tangent, if you divide radical 2 over 2 by radical 2 over 2, you get 1. So let's get rid of this right triangle, and it's 45 degrees. To change it to radian mode, 45 times pi over 180 is pi over 4. Okay, so you fill that information out on your unit circle. Our next triangle is a 30, 60, 90, except this time we're dealing with the 60 degree angle. So the short leg is 1, the hypotenuse is 2, the long leg is radical 3. So the cosine would be 1 over 2, and this time the sine would be radical 3 over 2. So tangent would be radical 3 over 2 divided by 1/2. That becomes just radical 3. Fill that out on our unit circle. Tan 60 is radical 3. 1/2 radical 3 over 2. This was 60 degrees. Change it to radian mode, we get pi over 3. The last part of quadrant 1 is that coordinate point 0, 1 up there. So first, it's undefined because 1 divided by 0. So the tangent of 90 is undefined. It is a 90-degree angle because it's straight up. It creates a right angle. And then to change that to radian mode, multiply by pi over 180, you get pi over 2. So that was quadrant 1. Now we'll talk about quadrant 2. I'm going to do the quadrant 2 really fast because it actually follows this pattern. It follows the pattern of matching, right? So this is negative 1, 0. We're just in the quadrant where it's negative then positive. So here is 120 degrees because we went 30 more. To change it to radian, we get 2 pi over 3. Notice that it matches pi over 3, so the coordinate point actually matches the pi over 3 one, except the x value is negative now. It's negative 1/2 radical 3 over 2. Add 15 points, we get 135 degrees. The tan of 120 is square root of 3 over 2 divided by negative 1/2, so we get negative radical 3, which again matches pi over 3 except negative this time. 135, change that to radians, we get 3 pi over 4. And that's negative square root of 2 over 2, square root of 2 over 2. Next one, add 15 more points, or add 30 to 120, you get 150. Tan of 135 is negative 1. 150, change it to radian mode, is 5 pi over 6. And we get negative radical 3 over 2, common 1/2. The tangent of that is negative radical 3 over 3. And then the last coordinate point I want to talk about is all the way 180 degrees. Change that to radian mode is just pi, 1 pi. Because remember, 2 pi is the full circle, so 1 pi is half of the circle. Negative 1 over 0, or sorry, 0 over negative 1, the tangent of 180 is 0. Okay, so that is quadrant 1 and quadrant 2. What I want you to do is complete the rest of the unit circle following the same pattern. Right? Quadrant 3 will be negative, negative, and then quadrant 4 will be positive, negative. So use the pattern in order to find the rest of the unit circle, and make sure you find the tangent for each angle. Alright, good luck on the practice.